1, this is 2.2, solving one-step equations. There are 4 different properties that they want to go into, and those properties are addition, subtraction, multiplication, and division, properties of equality. So we got properties of equality. So what we'll do here is properties of equality. And basically it highlights the one thing I got up on top there that I originally had. And it started, because if you can remember that rule, then it folds in the 4 below. What you do to one side of an equation, you have to do to the other. Have to. If you don't, it changes stuff. Think of it this way. You and I, right now, have the same amount of money in our wallet. Let's just say it. Okay? So let's say we both have $5. Okay. So we both have $5. If I add $2 to the amount I have, are we the same?
No.
No. But if I add $2 to me and $2 to you, are we still the same?
Yeah.
Yes. That's the addition property of equality. If I take $3 from both of us, do we still have the same amount of money?
Yes.
Yes. If I say, hey, I'm going to double both of our money, are we the same?
Yes.
And if I cut it in half,
Yes.
yes. That is demonstrating the idea of the addition, subtraction, multiplication, division properties of equality. Essentially, what you do to one side, you have to do to the other. So let's go into some examples. Now, the first problem we're going to attack here, if you want to say it that way, is C minus 22 equals 54. The whole idea for solving an equation, remember, is to get the variable, which they have in this problem, C, by itself. And the way you can kind of think of these is doing the exact opposite of how you read it. It's C minus 22. So to get rid of a minus 22, I'm going to add 22. And if I add 22 to the left side, I need to add 22 to the right side. I want to see the steps. I want to see that you just canceled the 22s. Well, that leaves me with C equaling 76. Now, we just solved, hooray, but how do I know that 76 is correct?
You can plug it in.
You plug it in. You plug it back in where? In the original problem. So, I'm going to take C out and put in 76. This is checking. Guys, when you check a solution that you had, you cannot go across the wall. The wall I'm going to call is the equal sign. When checking, there is no properties of equality going on. You can't subtract 22 from both sides or add 22 or 5 or divide by 3. You can't do that. All you're allowed to do when checking is to simplify left side, simplify the right side. And what you do at the end is you kind of peer over the fence or that wall, which is the equal sign, and you say, are we the same? Yes? Awesome. No? Then we better go back and fix it. We better go find another answer. And so what's 76 minus 22? So this is 54 equals 54. I bring the 54 down. This 54 is just going to come along for the ride. And does 54 equal 54? Yes. Check. We're good. We checked it. We're happy. We know we got it right. Now, moving on to the second problem. 63 plus m is equal to 79. I have to. It's 63 plus m. Or if I read it the other way, it's m plus 63. To undo an addition of 63, I'm going to subtract. And to make sure what you do to one side, you do to the other. And what's 79 minus 63?
Oh, yeah.
16. So we better check. Yeah, we're not 100% sure. 63 plus 16. Notice 16 again is in parentheses because I took out m, leaving a hole that needed to be filled in with its value. And 63 plus 16? So 79 equals 79?
Yeah.
I think so. The next problem we'll do is 39 equals a negative 3r. I want to get r by itself. But if I was to read that, it's negative 3 times r. Divide what? Divide both sides by negative 3. To undo multiply by negative 3, I'm going to divide by negative 3. The negative 3's will cancel, leaving me with a positive r, because a negative divided by negative is a positive. And what's 39 divided by 3? It's 13. Now, notice that I left the negative off for now, because a positive divided by a negative is negative. So I can work with the negatives later, or I can do it first. So either one, I get a negative 13 equals r. Again, you better check it. 39 equals negative 3 times negative 13. So you say to yourself, negative times negative is a positive, so we might as well take care of those first. And what's 3 times 13?
39.
It's 39. 39 equals 39. We check. And another problem, I got to get q by itself. This one is an interesting one. We divided on the top one, so it seems like the only one we haven't got is the multiplying one. I got a fraction. I've got 2/3 times q equals 1/2. It's fractions. Most of us don't like them. It's okay. All I have to do is get rid of the 2/3. And you guys are like, oh, just divide by 2/3. That will work. You can divide both sides by 2/3. That would be perfectly fine. These will cancel each other. The only problem is that now you've got a half divided by a 2/3. That's a complex fraction. First of all, we don't like to divide by fractions, so what do we have to do? Multiply by the reciprocal. So q would equal 1/2 times, what's the reciprocal of 2/3? 3/2. And how do you multiply fractions? You multiply fractions going across. So 1 times 3 is 3. 2 times 2 is 4. And now you have an answer. Now, I'm going to go back up here. I'm going to redraw it and say, was there a different way to do this? Could I have multiplied instead? Yes. Well, what happens if I said, let's just multiply by the reciprocal to both sides? What's on the left side? What's 3 times 2?
6.
What's 2 times 3?
6.
So wouldn't that have been 6q over 6
Q.
equals
1.
3/4?
Oh.
And 6 divided by 6 is
1.
1. And then q would equal 3/4 anyways. So your choice. Personally, for me, I like to multiply right away by the reciprocal, which is the stuff in the red. Otherwise, you can divide it out and then flip and multiply. It works out fine. Obviously, we better check that. So the original problem was 2/3 times 3/4, yeah? Should equal 1/2. 2 times 3
6.
over 12 equals 1/2. And 6 divided by 12, which is 1/2, or 1/2, equals 1/2. Check.